the Gifted and Talented Specialist at St. Louis Park. I wanted to take a moment to teach you a little bit about Krypto. It's a little bit hard to explain. I take quite a bit of time with the students to go through many examples and work with them for multiple weeks and before they really do understand the concept of Krypto. Krypto is kind of a game, a way to play with numbers and math. The goal is to make as many different equations using 5 numbers and a circled number. So there's a few rules that you have to follow. The first one is that you must use each number once and only once. You do use those first 5 numbers to equal the circled number. And I'll show you an example below. Students may add, subtract, multiply, divide, use squares or square roots. For the younger kids, I give them the squares and the square roots, but I continue to explain what a square number is and what a square root of a number is. So if we start out with our first example, the numbers are 2, 3, 4, 5, 6, and then the circled number is 10. And so the first thing I have them do is just add all 5 numbers together. 10, 15, 20. So then I have them compare the 2 numbers. So 20 is the total, 10 is the circled number that we're going for. So and I'll say, it's about, is it less, is it more, is it half? What operations will we have to use in order to make it smaller in this case? And so they would say subtraction or division. And the younger kids don't know division, but again, we work through examples so that we can get to a point where they're understanding division on a simple level. Then probably one of the most important pieces is that they start looking at relationships between the numbers and how they go together. Over time, I've found that the students really develop this wonderful concept of numbers and how they fit together and patterns. So here I might say, oh, they're all 1 apart. Well, what if I subtracted 2 from 3? Well, what's 3 minus 2? 1. What makes 1 a good number in this problem? And then we talk about how if you get kind of close, you can add 1, subtract 1. We talk about multiplying by 1. So if you can get the number, it gets the kids really close. I also might ask them, what other relationships do you see? If you add 2 and 3, you would get 5. If you multiply 2 and 3, you get 6. And 2 plus 4 is 6. 6 minus 4, a variety of relationships. And I have the kids kind of pull out those relationships. Then we teach them about the squares. And I have an example here. I say that x squared is that number times itself. So we would go through and say, what is 2 groups of 2, 3 groups of 3, 4 groups of 4, 5 groups of 5, 6 groups of 6. And most of the students are able to get that, even at a 2nd grade level. The square root, especially at the youngest levels, I just give that to them, but I explain it. If you have a number and you divide it by another number, the answer is the same as that number. So we say 4 divided by 2 is 2. So 2 is the square root of 4. And then usually I will start out with, if we know that the numbers, you try an operation. Once you take 2 numbers and do something to them, the numbers that you don't use, I put in a bracket. So I'm going to flip this and we're going to go on and I'll go through it a full example. So you start out and you have 2, 3, 4, 5, and 6. 1, 2. Oh, and our answer is 10. We're looking for 10. Above and below it, I am putting the squares. So we have 4, 9, 16, 25, and 36. And the only number that we can get an even square root is 4, and that's 2. And so what I tell the kids is they can use one from any of these numbers. For example, on 4, we could either use a 16 or a 4 or a 2. And they learn that. They kind of grab onto that pretty quickly. We added all these up. We said it was equal to 20. And so we want to get to 10. So we know we need to make it less fairly quickly. Especially in the beginning, I give them kind of a quick, I take the two largest numbers and subtract them, because then we get rid of a lot at once. So if we started out and we said 6 minus 5, that's equal to 1. And then I asked them, well, what numbers have I not used? 2, 3, and a 4. And remembering that our ultimate goal is to reach 10. So I have 1. So if I say 1 plus what number equals 10, they tell me 9. So if I can make these equal 9, I can add 1 and we'll get 10. I also say what number minus 1 equals 10. So it could be 9 or an 11, because 11 minus 1 equals 10. And then the last one we talked about multiplying. So if we take 1 times what number equals 10? 1 times 10. So this is a really great number to use because because they're so close, 9, 10, or 11. So let's just next add up what's in here. We have 4, 5, 6, 7, 8, 9. Well, there's our first one. So remember that I said I want how many different ways can we get it. So first of all, we're going to say, well, if I just add them together, if I say 2 plus 3 plus 4, that is equal to 9. And then I'm going to bring this one over here, add that one, and we have 10. So that's one way. We could also look at, if we put our squares up here and our square root, is there another way to get 9, 10, or 11? And usually somebody will say, oh, there's a 9. And, we need to remind them you have to use all of the numbers, but only one time. So I might say, what's 16 minus 6? 16 minus 6. And wait. Okay, 16 minus 6 is 7. Okay, so if we have 7 and we want to get 9, 10, or 11, what could we do? We could say, so we'll do 16 minus 9 is equal to 7. I might add I can add a 2. That would equal 9. And then bring that one back around, add 1, and get 10. This is a really good number because there's a lot of different ways of doing this. I could also take my 16 minus 9 equals to 7. And I could take 2 squared, or 7 plus 4, is equal to 11. And I can bring this around and subtract 1, and we get another 10. So here we have 3 different ways of doing 10, starting just with 6 minus 5. Now, if for some reason something doesn't work, we get an odd number, I just ask the students to make a line through it because I want to see that they're working or trying different things, even if it doesn't work. I want to give them credit for doing the work. So I'm just going to try another one. So I did 6 minus 5. I'm going to do 6 minus 4. That's 2. And then I have to, in my bracket, I'm going to put the numbers I haven't used. So I used 6 and 4. I have not used 2, 3, and 5. Now this is a little bit tricky, and sometimes kids get a little confused because the 2 and there's two 2's, but this one was created by doing an operation, 6 minus 4. So they will actually end up having two 2's to work with. So we're going to ask that same question. If I'm trying to get to 10, if I have 10 minus 2, it would be 8. So 8 plus 2. I could also ask what number minus 2 is 10, or 10 plus 2 equals 12. So if we can get it to equal either 8 or 12, then we can add or subtract the 2 to get 10. So first I have them look without squares. It's 5 plus 3 plus 2. And they'll say, oh, that's 10. That's what we wanted. We wanted 10. And it's like, oh yeah, except when we have this 2 over here. So what are we going to do? So it did equal 10. We need it to be 8. Let's see. What if I did it with my squares? Let's see. I had a 4 and a 9 and a 25. So I put those above it. Okay, and because I've been doing this a long time, I quickly see it. If I add the 5 and the 3, 5 plus 3 is 8. And 8 plus 2 squared, or 8 plus 4, equals 12. And then I say, okay, so now we have this 2 over here. What are we going to do with it? We bring it down and subtract 2, and we get 10. So I'll ask the kids again at this point, are there other things we could do? Again, 25 minus 9. What's 25 minus 9? 16. Should we try it? And that's usually what I say. Should we try it? I don't know. Maybe it'll work, maybe it won't. So I'll say 25 minus 9, because I'm using the squares. Said that equals 16. And now I have a 2 or a 4. So I want to get an 8 or a 12. Well, there's actually 2 ways we could do this. They could follow it like the one above and subtract 4. That would equal 12. Add or subtract the 2 and I get 10. Or I could also say 25 minus 9, 16. And then we could, using the base, divide that by 2. 16 divided by 2 is 8. Bring this number down. 8 plus 2 equals 10. So you can see really quickly that, especially when they're younger, I'm going to try to give them numbers in which they can manipulate back and forth and really find a lot of different patterns. And we would probably do a lot more examples. I'm going to stop for right now. Just try one. It's really important I try to get one that doesn't work so that they know, well, I don't get some also. Sometimes I can't find an answer, and that's okay. And then I just put that line through it. So once again, rules really quick for Krypto are you must use each number once and only once. The first 5 numbers have to equal the circled number. You may add, subtract, multiply, and divide. And it's very interesting as they get older, they start making their own rules, such as, well, can we cube numbers? Could we use, numbers to the 4th power? If they know how to do it, go for it. So I have really found that the kids' concepts and understanding of numbers really expands. Some students pick it up fairly quickly. I've had a student that it took about 3 years. And the fourth year she came back and was so proud that she finally made it. So I just ask them not to quit, just try, listen in class when we do the examples, and over time they start picking up ideas. Sometimes it's just in the computation pieces. Otherwise, sometimes they start seeing the patterns better. But I think overall you're going to find that this is a great way to play with numbers and expand their knowledge of mathematic operations, numbers, and just playing for fun. Thanks.